Yes, welcome to Introduction to Physical Laws for level 4, 5. We are able to understand. I think this one I have also used in high school. This is basically for fluid dynamics and also physical science. We are doing this because of our course in mechanical engineering. You need to understand some of these forces so that when you are designing systems, you are able to understand how it relates. So in simple terms, we have what we call Boyle's law. As you can see from the animation, Boyle's law or gas law is a law that explains how variables can change in a system or in a confined environment. Try to explain the relationship between temperature, pressure, and volume. If you keep temperature constant, but you try to vary pressure, when temperature is kept constant, but you vary pressure and volume, you realize the pressure, when the pressure, for example, when the pressure increases, the volume will reduce. But when the pressure reduces, the volume increases. So you are looking at inversely proportional proportionality, where the change in pressure affects the change in volume, and when you take pressure times volume, you get a constant K. This constant is what we call temperature, because under normal circumstances, if temperature is not changing but you're only changing pressure and volume, then you have what we call Boyle's law. PV equals to constant of proportionality. For example, here, if the volume is 30%, pressure is always high. But when the volume is 60%, pressure when the volume is 30%, pressure is very high. But when volume is 6%, pressure is high. Which means when volume is less, pressure is higher. But when you increase volume, pressure tries to reduce. As you can see, very high and not totally different. Where do we apply this? We can apply Boyle's law in our air brakes, like train or our trucks. They normally apply this because for them to do braking, they must ensure that for pressure for these air brakes to work, they must compress air to a small volume. When this air is compressed to a small volume, then automatically the pressure is high, and this high pressure will impact on the brakes to stop the train or the trucks. So they normally utilize the air brakes, that is the Boyle's law, to ensure that they apply in train and trucks. Also in scuba diving, gas storage cylinders and breathing apparatus design rely on this principle of Boyle's law. You can also apply in internal combustion engine. When an engine is working, normally, for example, if I use a petrol engine, when the fuel is injected into the cylinder and the air is also injected into the cylinder, for example, it will be compressed in a small volume by the piston. That small volume, called a combustion chamber, when it's compressed, it develops high pressure. Because of high pressure, it will now create work done, where energy, let's say there's energy generated, which will now push piston down to ensure that it moves up and down. So these laws are applied across many areas. We can look at Charles' law. Charles' law also tries to explain the relationship between pressure, volume, and temperature. But in these circumstances, this subject did an experiment, but instead of holding temperature constant as Boyle's law did, he held pressure constant. From this holding pressure constant, he varied volume and temperature to see how they behave. But in these circumstances, then he obtained a direct proportional. When you increase volume, temperature increase. When you reduce volume, temperature also reduce. Then he gave us a direct proportion. This is what the relationship V over T gives you constant. You can apply this in also in hot balloon. Hot balloon, where air expands. When air expands with heat, it creates a lifting condition. This is called Charles' law. Because under normal circumstances, if this temperature expands in that, let's say if the air expands in a balloon, it is creating heat. And if creating heat, the air becomes lighter, and then the balloon is lifted. So we call it Charles' law. Also in gas turbine engines, the air expansion drives the turbine. Why? It is generating heat. Call it steam engine. When you say gas turbine engine, they are steam engines. So when air expands, it generates heat. Because once it expands, it acquires heat, and it becomes lighter, and it carries the heat with it. So the high heat now goes into to drive jet engines. So that on the basis of what? Charles' law. Also heating, ventilation, and air conditioning systems. The normally heating and cooling processes normally account for volume changes with temperature. So for this one, I normally use in systems. Maybe an environment where they lost temperature. Air, when air heated, it acquires heat. Then it becomes lighter. It moves from point A to point B, giving out heat. So that's why they're using heating and cooling systems. You can look at another law called Gay-Lussac's law, or the simple term gas law. Also, this somebody tried to do an experiment to also look at volume, pressure, and temperature. When he held volume constantly, he realized that pressure and temperature are related directly. If you look at Boyle's law, he's looking at the relationship between volume and pressure. But looking at Charles' law, he's looking at the relationship between volume and temperature, which means the other variable pressure is held constant. But this guy, called Gay-Lussac's law, he tried to do an experiment between pressure and temperature, but he held the volume constant. But what did he obtain? He obtained that the pressure is directly proportional to absolute temperature. Why? Which means if you increase pressure, temperature increases. If you reduce pressure, temperature reduces. We call it Gay-Lussac's law. Where do you apply them? These are simple areas where you can apply this. We can apply we can apply in pressure cookers. As temperature increases, the pressure rises to cook food as faster as possible. So pressure cookers are applying what we call Gay-Lussac's law. I know you have used pressure cookers. So when when they are keeping volume, because volume is kept constantly, but when you tighten your lid, you put the pressure cooker on your cooking vessel. When you increase the temperature of maybe your heat, the pressure inside is increasing, and this increase in pressure inside, it causes the food to cook faster. Then gas cylinder safety also. Overheating prevention is very key. To avoid this, the pressure buildup. So for this pressure buildup, they are using Guy's law to prevent overheating. Then also boiler design. Safety mechanism that accounts for pressure, temperature relationship. They have studied this scenario for pressure and temperature, because if you don't control it, it may cause danger. So the safety concern, they understand how they are going to design their boiler. I'm not going to explain this in detail for level 4 and level 5. Then you have another what we call ideal gas law. Another gentleman came to combine now the three laws: Boyle's law, Charles' law, and Gay-Lussac's law. The three laws. Boyle's law, he combined Boyle's law for P and V. He combines Charles' law for V and T, and he combined Gay-Lussac's law for P and T into what we call ideal gas law, to give a single equation where P is the pressure, V is the volume, and N is the number of the moles. You will understand that one, don't worry. Then R is the universal gas constant, and T is the temperature. Where in this law, he obtained that P, pressure and volume, is equals to number of moles times the universal gas constant times the temperature. Yes, they are. If you look at this, they are inversely proportional. Inversely proportional. Pressure, volume, the change on one variable will affect and also adjust to maintain balance. If you change pressure and volume, the other one here, because now N and R may be constant depending on the material. So if you change pressure and volume, temperature will also change. The inversely proportional. An example of application like thermodynamic cycles, Otto cycle, diesel cycle, Brayton cycles in engines, internal combustion engines and steam engines. You can apply Otto cycle, that is petrol cycle or diesel cycle, and Brayton cycle, where you are trying to vary pressure, volume, temperature. Pressure, volume, temperature. Mole concept will come into play. I don't know how to explain that. Then also compressor and turbine design, they have to apply the fundamental of PV equal to nRT to ensure how the system will compress, to ensure how the system will expand, to ensure how the system will contract for the efficiency operation of the compressor and turbine. Also, refrigeration systems, they have to predict the performance of the air conditioning system AC and the refrigeration systems for the purpose of ensuring that they vary pressure, volume, and temperature. That is what we call ideal gas laws. Then we have what we call Hooke's law. Hooke's law, in simple language, is about understanding the elasticity of a material. When you apply a force, for example, if on a spring, it elongates. So there's a linearity that it takes. We call it elastic limit, elastic probability or elastic limit, where it is not beyond the deformation. So the tension or the extension of a spring is directly proportional to the applied force, but within the elastic limit, and where this K is the spring constant. This depends on the material of the spring. So when you apply a force, for example, let's add a force here. If you add force, let's say let's add two forces. You see, let's reset. If I add force one force, what does it do? Let me reset. It is now at this point, there's no force. But if I apply a force here, if I add force, it elongates. If I add more force, it elongates again. Another force, it elongates. Like that. You see, every time I'm adding force, the system is elongating. Until a time it cannot go beyond. You see now, it is now maximum. I cannot add. If I add more than that, it cannot go beyond. Let me reset again and then start. If I add one force, note what it's doing. It is elongating. It is elongating. It's elongating. It's elongating. But it is now reached 6. Within now elastic limit, it has gone beyond. If I add more forces, it cannot elongate, which means it has loosened the elasticity. We call it Hooke's law. Hooke's law. So it must be within elastic limit. Yes? It must be within elastic limit. As you can see, the other one, for example, on Gauss-Lussac's law, if I apply it, what does it do? Because this one is directly proportional. When you increase temperature, pressure increases. It is heating now here. You see? It is heating. What we'll be doing, let's go to ideal gas law, also the same. You'll see a Hooke's law. If I reset, I apply a force, what does it do? The more I apply, now it has reached 6. It cannot go beyond 6, which means it is within elastic limit. But if I go beyond 6, it cannot go beyond 6 because it's losing elastic limit and it is going to plasticity. You can apply this in suspension springs, leaf spring, shock absorbers in vehicles, in aviation industries, all of them that are applying suspension, so that you design this spring depending on Hooke's law behavior. Because if the spring goes beyond, you'll hear somebody say the shock absorber has reached, maybe it needs to be repaired. It cannot hold beyond, and you need to change it. Also in strain analysis, this is the fundamental when you're doing the behavior of material to understand how it will behave under different loads. You can also apply this. You can apply in measurement devices like spring balance and load cells. Use this principle of force measurement analysis to understand how you are going to apply the ideal gas law, and also how you're going to get the output. Then lastly, force is on Newton laws of motion. The Newton laws of motion, there are normally three, let's say linear motions: first law, second law, and third law. On the first law, a body normally remains or in uniform motion unless when you kick a ball, the ball will go in a straight line. For example, if you confine it to a straight line, it will move to a straight line. Unless now you apply an external force to change that force, that motion of that body, it now deviates. So the law of first law is called inertia. For example, you are in a car. The car is moving and you're seated. If this person applies a brake, you realize that your body was still in motion, and it's like it knocks in the front, because it's like your body was also in motion, but he has applied force directly. So if you apply force directly, or maybe it stops the vehicle, you realize your body knocks in the front, which means it was still undergoing force. Then another second force called force. Second force, that is, you apply acceleration. You see, this is a second force. Force is equals to rate of change of momentum, where momentum is equals to m into bracket v minus u, final velocity minus initial velocity. You get more momentum. So this is what we are using, or mass times acceleration. You get what? Momentum. Third law: for every action there is an equal and opposite reaction. Yes, for every reaction there is equal and opposite reaction. So the first law is about inertia, second law is about force and acceleration, then third law is about action and reaction. So this one describes the relationship between the body and forces and how this will affect their functionality. Where can you apply? There are so many of them. You can apply to look at the safety systems like safety belt, seat belts and airbags, counteracting inertia during collisions. You can look at robotics and structural design when looking at the force calculation for the purpose of machinery and structures to balance these forces. You can look at this second law. You can also apply in propulsion system like rocket engines and turbine engines to understand how they work on the principle of action and reaction. Action and reaction. To summarize, some of the laws, basic laws of engineering we have looked at. Boyle's law is looking at the relationship between force, pressure and volume, like compressors, gas turbines, engines. Charles' law is looking at the relationship between volume and temperature. Gay-Lussac's law is looking at the relationship between pressure and temperature, and these are the relationship, which means they must be constant. Ideal gas law are looking at the relationship between volume, pressure, and temperature, at the same time introducing what you call a universal gas constant and also more number of moles, or mole concept. Hooke's law is looking at the relationship between force and extension or elongation. And in this scenario, you can also look at the stress-strain relationship using Hooke's law. Newton's first law is about inertia. Second law is about force and acceleration. Third law is about action and reaction. So these are the backbone forces that forms the mechanical, civil, aerospace, and electrical engineering that provides foundation for design, simulation, and problem solving across engineering disciplines.